Hello everyone. So in this video we're going to go through more examples of section problems from section not 6.3, that should say section 8.3. Okay, so I noticed that we all had trouble on section 8.3, and I don't blame you because it is probably the hardest section that we're going to do. Okay, it brings all of the concepts together, and so there's no shame in struggling. Okay, it also doesn't help it that I messed up the videos and the notes, so I don't take any blame, or rather I do take some blame there. Okay, so we're going to go through 4 examples here, right? And I have them written down here, and I have the answers, the proper answers beside each of them, so I make sure that I don't forget any this time. So we'll start off with this example. 4 sine squared of theta minus 2 is equal to 0, and I'm trying to find the solutions from 0 to 2 pi, inclusive on the 0, non-inclusive on the 2 pi. Okay, and it turns out that the 4 answers are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So let's see how we get that. So the first thing that you're going to want to do in any of these problems is try to get sine of theta or whatever trig function that we're using by itself on one side. And so here that's not really a hard problem. So I start off with 4 sine squared of theta minus 2 is equal to 0. With some algebra, I can get down to sine squared of theta is equal to 1/2. Okay, and then if I take the square root of both sides, I get that the sine of theta is equal to plus or minus 1 over the square root of 2. 1 over the square root of 2. So I have to deal with the plus and the minus. That's what's going to get me the 4 different answers. So I'm asking the question, where or for what values of theta is sine of theta equal to plus or minus 1 over the square root of 2? So first, let's think about, do we know a special triangle where the opposite side of an angle is 1 and the hypotenuse is square root of 2? And the answer is yes, you do know where that happens. The special triangle that we've talked about, that's hardly written, so let's do that. There's a triangle for an angle theta here where the opposite side is 1 and the hypotenuse is the square root of 2. That angle in here is pi over 4, or 45 degrees. So we're working with a 45, 45, 90 special triangle. Okay, great. So I need to think, so there's one answer, but that only deals with, if I draw the xy plane, and I have quadrant 1, 2, 3, and 4, that only deals with the example in quadrant 1, where the angle here is pi over 4. That's going to get me 1 square root of 2 there. Okay? But there are, in fact, 4 different triangles that I can make in the xy plane that give me some form of 1 over the square root of 2 with a plus or a minus somewhere. Okay? So that's the first example. Okay, that's the first one. Sine of pi over 4 is equal to positive 1 over the square root of 2, or square root of 2 over 2. Okay. Where else? Well, I can make a similar triangle in quadrant 2. Okay, where this reference angle inside is pi over 4. That's going to give me an opposite side of 1 and hypotenuse is square root of 2. Okay, the third side down here is -1, and over here it was 1, but we don't care about that at the moment. Okay, I have another triangle here, pi over 4. Okay, gives me 1 over the square root of 2. But this pi over 4 is actually a reference angle for the larger angle here, and that larger angle is the theta that I'm looking for, and that theta is 3 pi over 4. Okay, how far does it take? I know that 180 is pi. Okay, so from this point, from this angle down to theta, it's pi over 4. So that means that the other one must be 3 pi over 4. So if you check, you'll see that sine of 3 pi over 4 is equal to 1 over the square root of 2, or square root of 2 over 2. So that's my second solution there. Okay, and so if the question just asked 4 times the sine of theta minus 2 is equal to 0, then those two would be the answers. Okay, those two would be the correct answers, and that would be it. But I now have that sine squared of theta is equal to 4 sine squared of theta minus 2 is equal to 0, and so when I have squares in there, it turns everything positive, and so I have solutions in quadrant 3 and quadrant 4 as well. Okay, so you remember that sine is positive. Sine's positive in the first and the second quadrant, and sine is negative in the third and the fourth. Okay? So we'll move to a third color here. Where else would we find solutions? So we're going to find, I'll take that away. We're going to have another triangle, same as the other ones, where the hypotenuse is square root of 2, and the opposite side is now -1, okay? Because the answers are when sine squared of theta is equal to plus or minus 1 over the square root of 2, okay? The angle in here is again pi over 4. How far is it from pi to pi plus pi over 4? That's going to be 5 pi over 4. 5 pi over 4 is equal to -1 over the square root of 2. So there's the third solution. And then the fourth solution is in the fourth quadrant. Hypotenuse of 2, opposite side of -1. Again, the inner angle in here is pi over 4. So how far is it, or what's the point of the angle here when I go all around? So that angle plus pi over 4 is going to get me to 2 pi, which I could rewrite as 8 pi over 4 if I want an over 4 denominator. And the answer there is 7 pi over 4 is going to equal -1 over the square root of 2. Okay, or -√2 over 2. And so there is that fourth answer, 7 pi over 4. Okay, so hopefully that made some sense. Okay, I know that many of you had trouble working with squareds, both in the worksheet and on MyLabs Plus, so hopefully that gave you some guidance there. Let's move on to the second example. Hopefully you can see this. The sine of 2 theta minus pi over 2 is equal to -1. Okay? So, again, I want the solutions from 0 to 2 pi, and it turns out that the answers are 0 and pi. okay? 0 and pi. So I'll rewrite this in my own handwriting down here. Sine of 2 theta minus pi over 2 is equal to -1. Okay. This is a situation where there's something more complicated inside of sine than I want to deal with. So I'm going to rewrite all of this as alpha. Alpha equals 2 theta minus pi over 2. And I'm left with the sine of alpha equaling -1. Okay? So, I want to find where the sine of alpha is equal to -1, okay? And then I'll use that solution and this equation here to sort of backtrack. All right? So, -1 results from a quadrantal angle, okay? So you won't get, there's no special triangle that'll get you -1. We need to think about it another way. So maybe the easiest is to think about how sine looks. So the sine of theta starts at 0, 0 here. It peaks at pi over 2. It peaks with a y value of 1 at pi over 2. And then it comes down, it hits 0 at pi. And then it hits -1 at 3 pi over 2. And then back up to 0 at 2 pi. So where is sine of alpha equal to -1? When alpha equals 3 pi over 2, okay? So I'm asking what's the y value when the x value, or here it's the alpha value, is equal to -1, okay? So it's the sine of 3 pi over 2 equals -1. Okay, so alpha equals 3 pi over 2. But of course, that's not the answer for theta. I want the solutions from 0 to theta. So I'm going to use this equation up here to solve. So I get 3 pi over 2 is equal to 2 theta minus pi over 2. I have to add pi over 2 to both sides, get rid of it. And so I get 4 pi over 2 is equal to 2 theta. Okay. 4 pi over 2 is just 2 pi is equal to 2 theta. So theta equals pi. All right. Great. So there's one answer, pi. Okay, that's maybe the more obvious one. What about 0? What about 0? Well, since I now have 2 theta inside, now I have to go back and think about what's the period of this function. I know it's a lot to think about, but you need to, okay? What's the period of sine of 2 theta minus pi over 2? Okay, so if you think about what kind of shifts are going on, this minus pi over 2 is a horizontal shift to the right pi over 2. So that's not going to change the amplitude. But what will change the amplitude is this 2 theta, okay? And so the original period of sine is 2 pi, but this sine, okay, the period of this function, because we have 2 theta, it's always, to find the amplitude, it's always going to be 2 pi divided by whatever is in front of the theta. So here it's going to be 2 pi divided by 2, or pi. Okay, and so this answer, and so if I were to write this out for all possible thetas, I'd write that theta is equal to pi plus pi k, and MyLabs Plus writes it where k is an integer. Okay, I wrote it as where k is in -2, -1, 0, 1, 2, so on and so forth in both ways. They both mean the same thing. Okay, and so when k is equal to -1, and so if I write them all out here, it's theta, 2 theta, 3 theta in the positive direction, but I don't care about anything at 2 theta or above. But what's below, when I subtract away theta, I get 0, negative pi, so on and so forth. So I don't care about negative pi, but I do care about 0 and pi, so that's where the 0 comes from. Okay, so hopefully that's pretty clear. Now I'm going to stop the video here and create a second video that shows the last 2 examples. Hopefully that made it clearer. Okay, I'll see you next time.